Karen Greenhouse yet. Right now we want to get started promptly. So Karen, do you want to take over?
Yes, I will. There we go. Sorry, had to put myself off mute. Hello, everyone. Thank you for joining us today. And I know we're going to get more people as we get started, but let me introduce myself. My name is Karen Greenhouse. I'm the Professional Development Manager at Key Curriculum Press. And again, thanks to Elizabeth DeCarli, Andre Smarty, and Daniel Scher for joining us and answering your questions during the webinar today. Please remember to post questions in your question panel if you can't hear or see, or if you have a question, and that's what they're there for, is to answer those questions as we get along. Today's topics are on geometry and area and perimeter, and a couple things I want to say before we get started. All the activities that I am using today do come from our Sketchpad Lesson Link online subscription, which is a library of curriculum that supports Sketchpad. So every activity you see today does come from that. Some will be using pre-made sketches, and some will be doing things from scratch. You will get all of the documents, activity notes, sketches that go with each activity in a follow-up email. So just watch, ask your questions as you have them, and hopefully you'll get some ideas of things you can use in your classroom with your students. My goal today is to hopefully get through all four. Trying to incorporate geometry and dynamic geometry into your classroom is the goal of today. I am also going to be going through some features of Sketchpad 5. For those of you who have Sketchpad 4, you will see some of the newer features that are in Sketchpad 5. And every activity I use today can be used with both Sketchpad 4 and Sketchpad 5, except for the features that are in Sketchpad 5 that are new. You can't use those in Sketchpad 4, but the basics of each activity you can use in Sketchpad 4 if that's what you have. So we're going to start with triangles, and I chose this even though I know it's a very standard area formula that most students are aware of. I wanted to show you how you could use dynamic geometry to kind of make it come alive and give kids a clearer understanding of the area of triangles, no matter where those triangles might be found on the surface area of a three-dimensional object, upside down, part of another shape, that type of thing. So I wanted to send out a poll real quick to everybody, just getting you thinking about your students. So you're going to see a poll pop up on your screen, just a quick question, and if you could just answer that by clicking your choice and then hitting submit, and then we'll share the results. So think of your students that are about to come into your classroom for most of you pretty soon, I think. I know we have some middle school and high school teachers with us today, so a wide variety of students that you might be thinking about. And I have about almost everyone responding very quickly. Nice. All right, I'm going to close this, and let me just share the results so that you can all see this. And you'll see that we got about half of you saying yes, the other half you're kind of a no maybe. So for most, in my personal experience with my own middle school and high school students, most of them knew the basic formula of how to find a triangle. If we gave them the height and the base, they could do it. And unfortunately what happened is we tended to always give them a picture like the one that you should see on your screen right now, where the base usually was on the bottom of the triangle and the height was coming from that top vertex. And what happened is when you got a situation where the height and the base were not in those positions, or we started calling the height the altitude or the slant height, the students completely forgot how to find the area of a triangle. So what I want to show you is how you can use Sketchpad to create a triangle that can be any triangle and really clarify the concept for students. So I'm going to start using one of the new tools of Sketchpad 5, which is our Polygon tool. And the Polygon tool has three options. I'm going to choose this one that draws the sides and the interior. And I'm going to draw a triangle. And it's a very easy tool to use. You click for your first vertex, and you move your mouse, click to get your second vertex, and then you click, and the minute you have three, you automatically have a triangle. I click. If I'm done, I double-click, and it creates the triangle. But I could continue to click and move and create as many vertices as I wanted and create a polygon. So that's the new tool that makes just drawing polygons a little bit easier. So we have this triangle here, and I can make it be any triangle I want. so I only have to draw one, and I want to put in a altitude or a height. We want to make sure we're using the properties of altitudes, heights, which means they must be perpendicular to the base. So we're going to choose one of these sides to be the base. So right now we'll use our traditional, click the bottom side to be the base. And I want it to come from the vertex across from that base, so I'm going to choose that. In Sketchpad, you need to tell Sketchpad the what. I want it to be the what and the where. I want it to be perpendicular to this base, and I want it to go through this point, the what and the where. And I'm going to go up to construct a perpendicular line. So now I have a perpendicular, or altitude, and I can now move that around and create any triangle and move that base to be anywhere, so that it's not my traditional base on the bottom as we normally tend to show our triangles to our students. So we've got this triangle with this altitude moving around, and one of the things we want the kids to notice is this altitude, this height, is sometimes in the triangle and sometimes it's not. So let me label some of my points here, and this is just using the text tool to label my points. So what I want everyone to kind of be looking at right now, think of yourselves as your students. I want you to pay attention to what happens to, what kind of triangle do you see as I move this altitude? What happens to the triangle as the altitude goes outside? What kind of triangle is being created when the altitude is outside of the sketch? So I'm going to send you a quick poll real quick. This would be a question you'd want to ask your students. You're trying to get them to get an idea of the concept. What kind of triangles have the altitudes on the outside? So here is a quick little poll. So I'll keep moving so that you all can. And got most of our people voting here. And again, to answer the polls, all you have to do is click choose an answer and then hit submit. And okay, interesting. Now I'm going to close it. I know some of you haven't finished, but I am going to close it and we'll just share those results. The answer that you're hoping your students would get is that one of the angles in the triangle is obtuse. Whenever the, and let's go back to moving this, whenever the altitude is outside of the triangle, it is an obtuse triangle. So here it is outside and we have this angle right here is obtuse. And if I move it, I now have this angle out, the angle C is now obtuse. When it's inside the triangle, it's acute. So these are things when you have this triangle that you can work with and you can move around, not your typical static triangle that we tend to draw. You can make any triangle and get the kids to really start making that connection between the altitude and the base, wherever that base may be. Now I want to talk about very quickly what else could you do with this? Well, how do you help the students relate that formula that they know, 1/2 base times height, when the altitude is outside of the triangle? They don't know how to calculate that because they can't see that connection. So one of the things we teach them is to extend the base. So we're going to do that with by getting a line and making a line here. We're going to extend that. And now they can follow along and see that the altitude still remains perpendicular to the line that contains that base. So it's still perpendicular to that base. It's simply perpendicular outside of it. I can also actually define or kind of clarify this altitude so that they see it. So I'm going to go grab a segment, and what's about to happen, for those of you who have not seen this, Sketchpad 5, when you create something on a path, so the perpendicular is the path, and I am now creating a segment that represents the actual altitude. What's going to happen automatically in Sketchpad 5 is that that parent path becomes dotted, and it clarifies that this altitude that I've just created is part of this perpendicular. In Sketchpad 4, you would have to make that line dotted yourself. So I'm going to now really make this stand out by simply changing its color. And I'm going to hide the path, the parent path. So I'm going to choose that line and I'm going to display and hide it. So now I have this perpendicular this altitude that I can really work with, and I can start doing a lot more than just the formulas. I can have kids making some connections to the altitude. And one of the things we want to make sure they know is this altitude needs to be perpendicular. So another new tool of Sketchpad 5 is this marker tool, and one of its functions is to mark angles, put angle markers in. So this I know is a right angle because I constructed it to be perpendicular. So I'm going to get my marker tool, and you see it's a little pen, and I'm going to click the vertex of this angle, and I'm holding down my mouse, and I'm going to kind of hold my mouse and carry it into the angle, and you'll see an angle marker is created. And because this one was constructed to be 90, when I let go, it creates the 90-degree angle mark automatically. So now my students can see that even as this altitude goes outside of the triangle, it is maintaining its 90 degrees. I can also, I'm going to hide my labels because I want my students to get an idea that this is true for any triangle. So if I don't label it, I can talk about any triangle. What's the connection between the altitude and the base? Well, the altitude is always the perpendicular that is coming from the vertex opposite the side we're calling the base. So let's actually call this side the base. Give our students some connection, some vocabulary to add in here. And all I did is I labeled this line, this base, and then double-clicked, and I can change labels to anything I want. So I'll do the same thing here. I clicked it to give it its label, and then I double-clicked, and I'm now going to call this my altitude, or height, whatever we want to. So now these labels will follow my shape as I dynamically change it, and the students start making that connection. What else can they look at here? Well, what kind of triangle has the altitude as one of the sides? Well, it's a right triangle. So you can start making those connections without numbers or anything attached, and they really start getting the feel for what is an altitude, what's the relationship between the altitude and the base. Another tool that, since I'm in here, that I want to bring up is the hot text. The text tool in Sketchpad 4 and in Sketchpad 5, you can create a text box, and you can type as normally as you would normally. But with Sketchpad 5, you have what's called hot text, where it's a shortcut basically to get some things in there. So I'm talking about altitude and base, and I want my students to write down what they know about it, and they can write it right on the sketch. So maybe I can say, what's the relationship? So I want to talk about in triangle CBA, and just simply by clicking, as I move my mouse over here, and you see a plus sign, if I click it, it puts the name of that triangle in here. And then I can start typing has altitude, well, has an altitude. So I'm going to click, instead of typing in the word myself, if I click on this, see how I have plus sign, it gets that in there. And I'm not going to keep typing, but I could continue to type. And what I want to talk about here is, what is hot text? Well, it was nice. It got that in there really quickly for me, but it's also interactive. Makes it a interactive sketch, basically. As I mouse over this, anything created in hot text now becomes highlights. If I'm holding down the mouse as I go over it, and over here it highlights just by mousing over it, and if I hold it down it will blink. So hot text allows you to create very dynamic descriptions of the things you're creating as well, and highlights those components in the shape as you're doing it. One last thing I want to talk about in this, now that we have this dynamic sketch that we can talk about, you can also create dynamic calculations. And how do you do that? We have to get some measurements. So what do students know? They know how to find the area of a triangle, 1/2 base times height. So let's actually calculate the area of this and watch how it changes. So I'm going to measure the length of that base and the length of this height. I choose them, I go to measure, and I measure their lengths, and now I have these measurements up here. And as I change the shape, you'll notice those measurements are changing as the shape changes. So again, I can create any triangle that I want simply by drawing one in Sketchpad. And then I can make dynamic calculations. Well, how does that change as the triangle changes? So let's do one dynamic calculation by taking the two things I know and making a calculation using the Sketchpad calculator. So I'm going to go up to number. Those of you with Sketchpad 4, number is a new feature in Sketchpad 5, and the calculator, which used to live in Sketchpad 4, or still lives in Sketchpad 4 under measure, is now in number. So if I go under number, I get the calculator, and it's a normal calculator, but instead of putting static numbers in, I'm going to put in my measures that I've already done that are dynamic. So the formula that most students know is 1/2 times the base times the altitude or height. And now this is a dynamic calculation. It will also change as the measurements that created it change. So by creating this one triangle with the altitude and the base, you can give students the infinite examples of triangles so that they don't get stuck in it always has to have a base on the bottom. Now we have this triangle that can have a base anywhere, and they're making that connection that the altitude is always the perpendicular to a side from the vertex across from that side, and that side then becomes the base. And it gives you a lot more freedom with your students, especially as they get into more complicated things like three-dimensional, where they're working with triangles but they don't look the same, and we start calling the altitude the slant height. So this just gives them a much better visual and understanding of the concept of area. And I'm going to move on, but before I do, Elizabeth, is there any questions that have come up that I maybe need to address?
Just a reminder that when you're dragging the figure around and
stop
you're
talking,
sometimes your speech gets a little bit blurred, so try to
not do that.
Drag.
It is a very hard habit to break. I can just tell you right now. It's a very. I will try to be more conscious. I apologize.
Yeah,
okay.
And can you just one thing you could do is just point at your tool menu on the left and just say, this is the text tool, this is the marker tool.
Okay.
We've had a couple of questions about which is which. That's all.
Okay, so let me, real quickly, these are the construction tools basically of Sketchpad. So this is the, I forgot to turn my phone off, I apologize. This is the selection tool, or the arrow tool as we tend to call it, and that's, once you put something on your screen, that is the one that you use to select anything to perform a function on, measure, move, that type of thing. This is the point tool, it makes points. This is the circle tool, it makes circles. This is the segment tool, it makes rays, lines, and line segments. This is the polygon tool I talked about. We're going to be using this a little bit later as well. So it makes polygons, any type of polygon. They're not regular polygons, they're just polygons, and you can make as many vertices as you want with these, with interiors, sides and interiors, and just sides. This is the text tool. It labels points. It also creates text, hot text. This is the marker tool. It marks angles. It marks congruent marks, side marks, parallel line markers, and it also functions as a marker for whiteboard usage. And this is a new tool to Sketchpad 5 as well. So the new tools are the polygon tool, the marker tool, and this information tool. And the information tool is exactly that. It gives you information about the things that are on your screen. So if you go near something, it basically tells you about that thing. So, and you can mouse over it, and it's telling me at point B is independent, meaning it's not depending on anything to move. But if we go to this point is the intersection of this line AC and this perpendicular. So it even brings up things I may have hidden. So it just gives you information about the things that are on your sketch, because sometimes as you get more involved with this, you create these great sketches and you forgot how you created a certain component of that. So it gives you information, and they fade away once you are moved on after a little bit. Anything else, Elizabeth, before I get going?
No, I think you can go on.
Okay. So the next activity again is, the next two activities are about rectangles, and again because this is a relatively common middle school content. And the first one is one that is what we call a pre-made sketch, and again it comes from Sketchpad Lesson Link, and this is where someone else has created the sketch and your students and you are simply interacting with it. It becomes a great time saver. It also helps in this particular problem it helps make sure the students, we're trying to get them to discover some things about perimeter and area of rectangles and make sure that they're always working with a true rectangle. It forces them to work with a rectangle. So if you notice, someone else created this sketch, and no matter how I move this rectangle, it maintains its properties. I can't make it not be a rectangle. Therefore, the things I want the students to discover about a rectangle are going to happen because they're working with rectangles. These pre-made sketches, you can figure out how to make them by going up to display and doing show all hidden, but it's kind of scary when you do that. So just so you know, someone else did this. Just work with it, and as you get more involved in Sketchpad, you can figure out what they're doing by analyzing the sketches and the hidden parts. But we're just going to work with the sketch right now and let it help us and our students. So I'm going to do this one relatively quickly because it's a relatively simple sketch. The idea of this whole activity, and you're only seeing a couple pages from the activity. I just wanted to kind of demonstrate it. But this activity was to get students to really start making the connection between perimeter and area, and how do you find area? What's the formula from that? They can derive it from the activity as well. So the first thing they do after they realize they can only make rectangles is they're given a table, and this table is already created for you. Tables can be created in Sketchpad 4 and in Sketchpad 5, and this one's already done. And basically, if you watch, as I move this rectangle, the measures in the table automatically will change. And the directions for the students are to find rectangles that have an area of 16 centimeters. So students are going to play around, and they may automatically go to this rectangle, and once they find one, they go to the table, and to save a row in a table, you simply double click on that row, and it saves this row and creates a new row that now I can create another rectangle. So I found one rectangle, so let's find another long skinny one. That usually is the first one that they do. And there's another one that has an area of 16 centimeters. It obviously has different side lengths, and it has a different perimeter. So we're going to save that one by double-clicking the row and moving to the next. And students would continue to do this throughout the activity until they have basically found all the 16 centimeter squared areas. And I'll just do one more. We'll do the other one that we know, 2 and 8. And obviously in this particular case they probably would go 8 and 2 and 1 and 16, 4 and 4 again, which is not different. So the question that they're asked in the worksheet, and all of these activities come with activity notes for teachers that kind of help you figure out what to do with your students, how to guide the investigation, and also a student worksheet. So the student worksheet asks these students, okay, what have you noticed? Which of these rectangles that you have found that have an area of 16 centimeters which one has the largest perimeter? And so the students look, and they're going to say, oh, it's the long skinny one, and they probably will also have the 1 by 16 in there as well. So the long skinny rectangles seem to have the largest largest perimeter, and the short squat ones seem to have the smaller perimeter. So at the end of this first section, they make the conjecture that to get the largest perimeter, you need to have a long skinny rectangle, and to get the shortest perimeter, you need something that's a square. So that's where we're going with this. And they could write down all their conjectures on their worksheet or write on the Sketchpad. So then the next activity kind of advances that conjecture, has them test that conjecture that they're getting on with. So okay, let's do the same activity, but this time we want you to find areas of 24 centimeters squared. Now as a math teacher, you should realize right now that they're not going to get a square as the one with the shortest perimeter because this is not a square number. So this activity is actually also solidifying what does that mean to be a square number. What's a square number? Well, it's something that creates a square, and they're getting an actual visual of that here. So they would do the same thing here. They're probably going to start right away knowing that, oh, I know the longest one's going to be this long skinny one. So they're going to probably start right away with that. And then their next, and we're going to save that row. And then the next one they're going to try is to make a square. Because for the shortest one, well, that's not big enough. And that's too big, so I can't make a square. Somehow I can't get a square in between there. So then they realize, well, it's the one with the shortest perimeter is the one that's almost a square. And you can start making the connection of, well, how is that area coming out? Where are these numbers, how are these numbers being used to create this area? And that's where that formula comes from. They can see it in the table. Oh, these are the factors. So you could use this activity as a way to review factoring with your students. You could, how do you get the perimeter from these numbers that you see up here? So you really could use this activity in lots of different ways with your students, and it gives the students a visual. They're recording data. They're trying to analyze the data that they have. So it's a great activity, and it's already done, and the students are just interacting with it and coming up with their own conjectures and then testing them out. There are many other pages in here, but the last thing, and we have this in most of the Sketchpad lesson link activities, there's always an explore more for those students who are really fast and get ahead, or just for all students. We want you to, what if? So now they can come up with their own activities, their own measurements. This is a limited model in the fact that it does only allow you to use whole numbers, but you could then take this and expand it using decimal numbers or fraction numbers, that type of thing. So the next activity is a little more complicated, and it is going to be a from scratch one. So before I move on to that one, are there any questions? I know I'm going rather fast, but I am trying to get through some of the activities, and especially the next one, which I know takes just a little bit more time. So Elizabeth, any questions before I move on?
Oh, just wanted to reiterate, I said this at the beginning, but not everybody was here yet. We will be sending you the sketch and the student activity worksheet that goes with it in a follow-up email, so you'll be getting all these materials. And these do come from Sketchpad Lesson Link, which is a library of activities that we have as a subscription service. So I just wanted to answer that question. And I think there's a question about smartboard use, but I'd like to save that till the end of the webinar, if that's okay.
Okay, sounds good. And I know we got this question last time about how to make a table, and so if anyone wants to see that, we'll also do that at the end. I'm trying to make sure I leave more time at the end today for questions and such. So we're going to move on to the next one, and again, this is an activity, but it's not a pre-made. It's one where you're going to actually construct something from scratch. And this is a great activity to use with students, particularly if you're really trying to solidify their understanding of the properties. So this is about rectangles, and they really need to know their properties of rectangles for them to construct a rectangle. Now, in the last activity, if you remember, we controlled the area. We kept the area constant, and we were focusing on perimeter and how can you have a constant area and how does that affect the perimeter. Can you have what's the largest, what's the smallest. This activity is we're going to control the perimeter. We're going to keep the perimeter the same and change the area. So think of this as that problem that tends to come up often. You have a certain amount of fencing, and what's the largest fence that you can create, to the largest area you can create to enclose your pigs or your cows or whatever. So that's this type of problem. How do you know, how can you calculate the largest area when you're given a set perimeter? So we're going to create a rectangle. We're going to construct it from scratch. And before we do that, I want to ask real quick, because this was designed to be a webinar for new and beginning users of Sketchpad. So I want to just get a quick poll of how many of you actually know how to construct a rectangle with Sketchpad that maintains its properties as it changes in size. So I'm going to just get a real quick kind of feedback on that. So if you could just answer that question. If you've never done that, that's good. If you have, this just gives me a little idea of how much time I need to concentrate on that. Wow, very impressive. Got quite a few people who have done this before.
Can you read the question again? Sorry.
I don't know if I can actually see. It's basically how many of you have ever constructed from scratch a rectangle that maintains its properties? It stays a rectangle no matter how you move it. All right. And there is the results. So for the most part, we have quite a few that have, so that's great. So I may go a little faster than necessary, so let Elizabeth know and I will slow down. there are lots of ways to construct a rectangle that maintains its property. We're going to do a very specific way because what I'm also trying to maintain in this particular construction is the perimeter. So I'm going to control the perimeter, so I need to construct this in a way that's going to be able to control my perimeter. So my first thing that I'm going to do is create a segment, and this is going to be my control segment. It's going to control the perimeter of my rectangle. So this segment is, think of it as the parent path. So I'm going to create another segment on that. And again, remember, this what's about to happen is a Sketchpad 5 feature. The minute I let go, it's going to make the parent path, that original segment, dotted, because this is now on that parent path. Is controlled by the parent. So the parent path is now a dotted line. So let's put some labels in here. This is A. And remember, in Sketchpad, the order that you choose the points is the order that they will be labeled. So I chose this second, that's why it's B, and that's third. So there we go. All right, so now what else does a rectangle have to have? So that's one. AC is now one side of my rectangle, and it is controlled by AB. It cannot be any longer than whatever AB is. I can make AB longer, and which would then allow AC to be longer, but AC is controlled by the length of AB. So here's the side, one side of my rectangle. I know that rectangles need to have two sides perpendicular to this side, so I'm going to create them first. So again, just as in the first activity, I want to tell the computer what to be perpendicular to, so I want you to be perpendicular to AC, and then where to be perpendicular, so I want it perpendicular at these 2 points. So I did the what and the where, and I go up to construct, and I choose perpendicular, and it creates those two perpendicular lines. And no matter how I move AC or A and B, those lines will remain perpendicular. So now I want to add in my other point up here, but I'm going to do this very specifically. I want to control the size of my perimeter, so I'm going to use the next part with circles. So I'm going to create a circle because I know a circle has a controlled length, which is a radius, and I know all radii in a circle are congruent, so I'm going to use that knowledge to help me with the next component. So I'm going to create a circle with a center at C and a radius of CB. Okay, so I chose the center and the point, and when I go up to construct, that is now one of my options. So it's going to create a circle at the center, the first point that I chose. So now it has a circle here. And you'll notice that now there's this perpendicular is intersecting the circle right here. And I'm going to put a point there. And we're going to label that one point D. So a couple things I want you to notice. DC is a radius of this circle, and BC is a radius. So right away, I know that these two sides are congruent. Even if I change the length of those, they're always congruent to each other. And if you notice, AC right here, and CB, they make this entire length AB. So AC plus CB is the same as AC plus CD. Right here, we have half of my rectangle. And so this is how I'm controlling the fact that my perimeter will always remain the same, because this component right here is always half of my rectangle, which is the same length as this right here. So I'm always going to be able to control my perimeter by the way I have constructed it. I am still missing the other side of my rectangle, so I'm going to get that in by using a parallel line instead of perpendicular. Parallel is the same as perpendicular. I will tell it what I want it to be parallel to, so I want it to be parallel to AC, and where I want it to be going through. So I want it to go through point D. And I go up to construct, and I choose parallel line this time. So now I have a parallel line. I have another intersection point that I'm going to put in here and label that E. So now I have my rectangle, and it will change size. It will change size this way. If I make this segment AB larger, it will make the rectangle bigger as well. I do want to kind of color the inside here, so I'm going to go back and use that Polygon tool, but this time I'm going to use the one that just colors the interior. Those of you with Sketchpad 4, to color an interior, you choose all 4 vertices and construct the interior. The Polygon tool allows you to do that in one step. So I'm going to basically follow the vertices again. I'm just clicking each vertex, and when I'm done I double click, and now I have the interior of that rectangle. So let's, oh, you know what? I shouldn't have done that. I wanted to show you another. I'm going to go back over it with the side one because I want you to see what happens to the parent paths. So all I'm doing is just going over it. I just wanted you to see that the parent paths become dotted lines if I do that. I had to use the side segments, so sorry about that. All right, so now what I want to do is actually get some measurements here to prove that this is maintaining its area. So I'm going to do it two ways first. I'm going to do it with the formula that the students are familiar with. So we first have to measure our sides here. So I chose all four sides. I'm going to go up to measure, and there are the lengths. I'm going to move those down here, and they will change. I'm going to make a dynamic calculation, again using my measures. Dynamic calculations, you have to have your measures that you're then going to use in the calculator. So again, my calculator is found under number. In Sketchpad 4, it's found under measure. So I want to do the perimeter. So the perimeter is the four sides added together. So we're going to simply put in our measures, and I'm clicking them and adding them. Okay, and so now I have my perimeter measure. And so I want you to watch the perimeter. Even though I am changing the lengths of the sides, the perimeter is maintaining. It's staying the same, and that is because of the way I constructed it. AC plus CD is the same as AC plus CB, so it's going to always, it's half the rectangle, so it's always going to maintain its perimeter because of the way I constructed it. I could have measured the perimeter quickly using Sketchpad, and I actually, with students, would probably do both so that they are using the formula, see where the formula comes from, but the quick way with Sketchpad is to choose the interior. So see how that's highlighted, and go up to measure, and perimeter is one of your choices. And the nice thing about doing both of them is you see the formula where it came from, but then you also see what it is, and you see that it is the same and it's not changing. Now it will change if I change the length of AB, but once I keep AB constant, then it maintains its length. So let's measure the area, do the same thing. So how do you find the area? The area is length times width, so let's work with AC and CD. So we're going to choose the measure of AC and times the measure of CD. So I'm going to go back and get my calculator, and I've already got the measures over here. So AC times CD, and that's the area. And again, I could do it the quick way with Sketchpad by clicking the inside and going up to measure, and now area is a choice. And so now as I change this shape, the area is changing, but the perimeter is constant. And so the question that comes up in the worksheet in the activity is, which rectangle, as you're moving this along, if your goal is to find the area with the largest, I'm sorry, I say that wrong, you're using the set perimeter and you want to find the largest area that you can enclose, you now have a visual that you can move and incorporate. And let's say you told the students that they had 20 centimeters of, yes?
Karen, number 2,
drag,
yeah. And then
sorry. It's so hard. It's such a hard thing to do. I'm so used to talking and moving. Sorry, I apologize. All right, so all I did was move it. I told the students, for example, you have 20 centimeters of, that probably is not realistic. We probably want to make that feet, but 20 centimeters of fencing, perimeter. What's the largest area? So I've set it to a specific number that I want them to then find the largest area, and then they can simply manipulate the sketch, the figure, till they can get the largest area. So they're watching this number over here, the 24.11 right now, but they're trying to find where's that number the largest. So we're just going to move this, and I'll stop talking, I promise. Here we go. All right. It looks like that was the closest I could get. So what's that shape look like? most students will say, wow, that looks like a square. Well, does that work for every length perimeter? So let's change the perimeter. Let's make it something bigger and see if a square is still the one with the largest area. So you could have students test out lots of examples and see if a square is the largest one. So it looks like it probably, oh yeah, 6, there it is. So it does seem like a square is the largest one. Well, how could we find that algebraically? Could we graph this? Could we kind of plot all the different areas? So that's the next step, is let's take it, let's make an algebra connection. Let's see where some of those things, how could we find this if I knew an equation or graphically? So how would you graph it using this information? Well, what is making the area? Well, the area comes from the length of a side times the length of the other side. So this side right here, if you notice, as I move it, controls how big or small the rectangle is. So as I'm there, okay, I stopped talking. So as I move AC, AC is controlling the area that we create for the shape. So I'm going to use AC, the measure of AC right here, as my input. That's my input. The length of that side determines the area. So I'm going to choose that length. That's my x coordinate. That's my variable that I'm going to use. What is the output? Well, by changing that, I get a different area. So my output is the area calculation. So I'm going to choose this as my output, or my y coordinate. So notice I chose the x and the y first in the order I wanted them, x then y. And when I go up to graph, I have some options here. And plot as xy is now an option because I chose 2 variables. So I'm going to choose that right now. And what that does is automatically put a grid up for me, and it plots a point. It plots the current value of AC and the area, which is right here. And how do I know it's a current value? Well, I could also measure its coordinates. So notice the point is highlighted right now. I'm going to measure it, and actually first I'm going to label it. What does this point represent? Well, it represents, and all I did was double click the label, and I'm going to put here that it represents the area. And I am now going to measure its coordinates. It's still highlighted, so I'm going to measure its coordinates, and we're going to move those to be up near the point. Very large, aren't they? And so if you notice, here's the coordinates of this point, and they match the current values of that side, AC, and the current value of the area. So there's a connection right there. Well, what's this? As I change AC, and I'm going to stop talking and do it, but as I change it, I want you to notice what's happening to the point. So I'm going to change the length or the input of AC, and it will change the output of the area. So follow the point as I do this. So basically, it's showing all the values of that area for that given perimeter. So it would be great if I could see that point, that path that it's going on. And you can do that in Sketchpad, another great visual tool for students. And you simply select what you want to see the path of. It can be anything. It can be a line, a segment, a point. And you highlight it, and you go to Display, and you should then see the option to trace whatever it is you chose. So I chose a point. So I'm clicking that, and now I want you to watch what happens. It's going to follow the path of that point, but trace that path as I move along. So you can see that now I have an algebra connection to my visual, my rectangle. So I can see all the areas. So when is the area the greatest? Well, we already determined that that was when we had a square. So if I go back and make that square where I determined, conjectured that that was the largest area, where is that on the graph? And that's pretty close. And it looks like that point is at the very top of my graph. All right, so you're giving the students a visual, a real-world meaning of that, if you're trying to make this algebra connection, of that vertex of my parabola, and really giving them an understanding of this is a real-world example of an algebra problem that they are used to. And what does it mean when we're way down here? Well, what's the input? It means the side is very, very small, which means it creates a very small area. So you're giving the students some real-world applications of the algebra they also have learned. So this is just a model that you can also extend this even further and actually, calculate the equation of this. You can, I'm going to erase my traces so that you stop seeing those. You can plot the locus of this and actually make the graph and have the students determine that. So what's the locus? We're going to choose C and the output here, and we're going to construct the locus, and it's going to create the path. Instead of tracing, it actually creates that locus. And now as I move, you're going to see the point following that path. So this activity had lots of things that you could do. You can expand it and you can make it as simple or as more complicated, making connections to algebra as you want. It helps solidify some properties of rectangles. It gets the connection between perimeter and area. It helps students understand what a parabola is if you are going to make that extension. So it's a great activity for lots of different reasons, lots of ways to make it fit all the needs that you might have in your classroom. And, oh my gosh, I've run out of time. So real quick, Elizabeth, any questions? I'm going to spend about 5 minutes on the last activity and try and save the last 10 minutes for questions overall.
Okay, so it doesn't look like we have any questions that haven't been answered, but okay. For all the folks out there in webinar land, think of your questions now. Karen's going to be doing one more activity quickly, and then we'll have a question period. So if you type some questions into the question panel, we'll read some of those out loud for her to answer for the whole audience.
All right, the last activity, I'm not going to do a lot with it. It's more, I put it in here as sort of a culminating, taking the three things I've already talked about and kind of giving you an application of how you could then use what the students have learned with the dynamic geometry and really apply it to something that tends to give most students difficulty, which is when we get into three-dimensional objects and surface area. They seem to forget all their formulas because we give them these horrible, 2 times the big base plus 5 times the, all these complicated formulas. So I'm trying to give you just a real quick application using a three-dimensional model. This is another one that is a pre-made, and it involves a lot of complicated things, so it is really for you to interact with. It's a great way to give your students a visual of three-dimensional objects and what nets are and where those formulas are coming from, and help students really apply the things they already know and get to surface area a lot quicker and more clear. So real quick, think of your actual students and what they might say to this question. I'm going to send out one more quick poll. Based on your own personal experience with your own students, which statement best describes your students' understanding of surface area? So that's the very last poll that we're doing, and then I'm going to quickly do a very quick overview of this activity. Okay, I'm going to close the poll even though not everyone has responded because it's going basically the way I anticipated on my own personal experience with my own students. My students always really struggled with three-dimensional surface area. And I think part of the reason is it's very difficult to have models that the students can visualize. We usually have those hard, cubes, prisms and stuff, and they can't actually see all the surfaces. They don't make that connection. So with Sketchpad, this pre-made model, and again, I'm only showing you a couple of the pages in this activity. You're going to get the entire activity, but I'm showing you just a couple pages. And we do also have things for prisms, but this is on pyramids. This is a three-dimensional model, that allows the students to actually see the three-dimensional object and move it. So I'm going to take this and spin it, and they can see all of its sides. You can change, the way it tilts so they can see all the component parts of it and spin it. And then it also has the net. And the great thing about this model is, let me spin that back where I want to look. The great thing about this model is you can change the number of sides. It's a dynamic model. And so I can make these bigger or smaller, and I can change the number of sides. Currently it's a triangle. Well, I could make it be four-sided. And now I've got this four-sided pyramid. I could make it be, I don't think you do 10-sided if I really wanted to. And what they're going to start making the connection is no matter how many sides I have, that simply changes the shape of the base and how many triangles I have on the lateral surface. So you're really giving them the connection that a pyramid, the sides are always triangles, and it's the difference being how many triangles I have on a side, and the base is always based on how many sides I have, and you can actually have them test and change it as much as you want. So you're giving students a great visual that they can work with, and they can change it, and they can make any pyramid they want with this model. And they start making the connection to things they already know. I mean, if you look at this shape and you ask a student to find the surface area, well, what is the surface area? It's made up of several triangles, which they already know how to find the area of. And this shape right here, which right now is a pentagon, and they may say, oh, I don't know how to find the area of the pentagon, but I'm going to show you how you can use this model and have students use what they know to do that. So here's this model. What do they know? Well, they know triangles. So I could actually take this pentagon and show them that this pentagon is simply made up of 5 triangles also. And they could find the area of that the same way. And we're not going to do that here. I'm just talking through this basically. They could find the area of this triangle, and they know they've got 5 of them. And they could find the area of this triangle, and they have 5 of them. And so all I'm doing is finding the area of a triangle. One of the things I know my students struggled with, especially when we got into 3D, is this height of the triangle, or the altitude. Well, they understood that when the triangle was laying flat or was two-dimensional. But now, once they get it in this three-dimensional, we start calling it something different. We call it a slanted height. So I'm going to just show you. And they get confused. They think that means something different. So if you can just show them that we call this the slant height, well, that's just because it's the regular altitude of a regular triangle, but because it's tilted in the pyramid, we call it the slant height. That's what I used to always try to describe to my students. So you're trying to give them a connection. Slant height's not different. It's exactly the same, and you're going to use the exact same triangle formula, but now you have a visual to attach it to. So this model allows you to first separate out what is surface area. So first they can go through how to find it, just the base. And so you focus on just the base, and you go through the things that they know, getting the altitude and finding the area, and they figure out, oh, that's all I have to do to find the area of this base. And then you can separate out just the faces, and again, you can change all of these models. Trying to remember not to talk. And they can find the area of the faces, and then at the end, you can bring it all together. Okay, here's one where we want the entire surface area. We want this base that is right here, and we want the lateral area, which is the sides of this three-dimensional shape, and you put it all together, and now you have the surface area. So I just wanted to show you this great model that is an excellent model to use with students, and it really allows them to manipulate and see things that are often very difficult for them, and they make that connection to stuff. Wow, I already know how to solve all this. I'm just putting things together that I already know. So I'm done, and again, I just want to remind you, you will be getting an email. It should come by Thursday that has the link to the recording and a link to the zip files of all the activities I've used today, which includes the activity notes, the student worksheet, and the sketches that were used today in their complete entirety, I guess is it, because I did cut some pages out of each one for the length of the webinar. So Elizabeth, are there any questions we have? I actually ended early this time. Woohoo!
Yeah, we have some time. So one question from before that I thought would be interesting for everyone to hear is about using Sketchpad on smartboards with students, interactive whiteboards. And I was wondering if you could talk a little bit about the point sizes and the line widths that are available now in Sketchpad 5 that make it a little easier.
Okay, so I'm going to go back to, I'm not going to use this pre-made. I'm going to go back to my the triangle one, which has these scary things going on right now. All right, so one of the things that we definitely included was now this marker tool. So that's definitely something that is making it a little bit more user-friendly with a whiteboard, smartboard type of thing. So you can use this as a regular marker and erase it. And also up here under the display, one of the new things is you can now change, unlike in Sketchpad 4 where you could only change the size of the lines, you can now change the size of the points as well. So you have 4 options now for points. You have dot, small, medium, large. So currently, I believe, let me change it. I'm just going to select a point. This point right now, if I select it and go to display, is currently a medium, which is the default for Sketchpad 5, but I could make it larger, and it would then be much bigger and much easier to grab if you are working with a smartboard. And the same thing with the lines. So if I just select one of these lines here, I have a lot more choices with my lines. I can change them to be hairline, which is, well, I'll show you what it looks like. It's very, very skinny. So that's if you just want to hide something. But I can also change it to be really thick. Again, much more compatible with a whiteboard. And you can also change the lines to be dashed or dotted. Lots of more options in this version than before.
Great. And I'll just add, you can also set the magnetism of points to be a little stronger. So if you miss the point on the whiteboard, if you're close enough, it will sense you there.
And to do that, you right-click and go to Property. Is that right? No. Where do you do that, Elizabeth?
I think it's in Preferences.
Oh, okay. Well, we'll do that later. Anything else?
Let's see, and is there a way to change preferences so the lines and points stay large without changing every time? I think once you've set them to a
right. Now that I've changed this point style to be large, every point I make from now on will be large until I change it back. So you'll see, because the last thing I did was make it large, all my points will now be large until I change it back.
Okay, and I want to, again, repeat what Karen said a couple times. We will be sending all the materials as well as a link so that you can view a video of this webinar. So if there's anything that went by a little too quickly, you'll be able to see it again and review it. We'll also be having a webinar next month on elementary topics. So if you have friends, colleagues that teach elementary level, if you could pass along the invitation to them, would be great. And we also do have online courses starting up in September for algebra and geometry and starting up in October for middle school and elementary math topics.
One thing I wanted to do, because it came up yesterday, so since I'm in this particular sketch, I'll just do it. The table that you saw in this activity, someone created that, but I did want to just go through, for those of you who've never worked with tables in Sketchpad, I just wanted to quickly show you how you can create a table, because you can create a table in Sketchpad 4, Sketchpad 5, and basically what you do is you have your measurements done and decide what you want in your table. So let's say I wanted to record and collect data on the different bases and heights and the area. So that's what I want in my table. That's what I select in the order I want it to appear in my table. So I want it to be the base, then the altitude, and then the area. That's what I want in my table. So I've selected those 3 items, and in Sketchpad 4, tabulate is under the graph menu. But in Sketchpad 5, it's under the number menu. But it's the same menu item, tabulate, for both. And I simply click tabulate, and it automatically creates a table with the 3 things that I selected in it. So now I have this table. It's got the current values, and if I like those, remember, I simply double-click them, and now I can change my triangle, and now I have something new, and I click that one. So that is how you can create a table, and you can plot table values. Now, it wouldn't make sense to plot these three, but if you're collecting a table with just an X and a Y, for example, you're plotting time and distance, you can collect data on that and actually then plot the table values. We're not going to do that now because it would be a silly graph, but those are the types of things you can do with table. There's a lot of functionality that you can do with table. You can make it automatically collect your data and that type of stuff. So that's the last thing I wanted to say. I wanted to go to my last page real quick and just give you some websites that you can go to. I have put all of these sketches in what we call a student web page, where if you want to go look at them right now, you could. And it's got the student worksheet only in there. So this is what we call a class pass. It's part of Sketchpad Lesson Link, where you can create student web pages and students can access them if they have Sketchpad. So if you copy that down right now, you can actually go look at those sketches. You will get the follow-up email, as Elizabeth said. You should get the email by Thursday once I've posted the recording. If you don't have Sketchpad 5, if you have Sketchpad 3 or you have Sketchpad 4 and you're just interested, you can go to this link right here and download a free trial of that and test it out. And there's also videos there to show you what's new and to show you how you can be using Sketchpad in your class, so that's a great place to go. You can also get a free preview of Sketchpad Lesson Link. If you like these activities and want to see some more, you can get those. And all these links will be included in your email as well if you don't want to copy them down, though I'm going to leave this screen up for just a little while if anyone's interested. And here's the link to the online classes if anyone is interested in those. So thank you very, very much for joining us today, and thank you, Elizabeth, Daniel, and Andres, for answering questions. And I hope to see many of you in next month's webinar.
And thank you all for attending. I know it's really late for some of you and really early in the morning for some of you. If you can take just a minute to complete the survey that you got when you exit the webinar, it will help us tailor these to your needs. So we really appreciate your feedback. Thanks so much for attending. Okay, we're going to leave the screen up for a few minutes so you can jot down the URLs if you don't want to wait for receiving the sketch. And then you can leave the webinar and complete the survey. Again, we appreciate you attending. We're signing off, but we'll leave the screen up for you, and we'll finish up answering a few questions.